Hello there, college algebra students. This is Mr. Kashi speaking. With this video, this is going to be our first lesson in our new chapter of Chapter 10, and this is on sequences and series. And the sections and the videos after this, we're going to really dive deep into sequences and series. This first video is just an introduction of what these all are and how to find different terms in a sequence and things like that. So just wanted to go over just some very simple definitions for some vocabulary. So what a sequence is just it's an ordered list of numbers and I don't want to redefine what a sequence is, so I'm just going to simply put some words here for these definitions. A finite sequence stops, and an infinite sequence keeps going. So just very simply, just the difference between those two. A finite sequence is going to have a last number, and an infinite sequence is not going to have a last number. And so what I wanted to do is just kind of show you what couple of sequences. These are pretty simple sequences, and usually what a problem is going to ask you to do is to find the next four. Okay, so hopefully you can see that here we're adding 5 each time. So you could keep going adding 5. So you have 22, and then you have 27, you have 32, 37, and then you could keep going if you wanted to. The next one is maybe a pattern that is a little bit trickier to pick up with. Here we're adding 3, and then we're adding 5, then we're adding 7. So then we'd have to add 9, so we'd go 26. And then we'd have to add 11, so that would be 37. And then it would be 13, so that would be 50. Then it would be 15, we get 65. And once again, you could keep going there as well. And then here, this is a different pattern. Our numbers are going down, and we're not adding anything. We're not subtracting anything. At first, it looks like we're dividing, but I'm going to explain this why we're doing this in a different video. But we're going to say that we're multiplying by 1/2. So we keep multiplying by 1/2. 32 times 1/2 is 16. 8, 4, and then you could say, okay, 2, 1, and then you don't have to stop there. There are such things called fractions, right? So half of 1, that would just be 1/2, and then half of 1/2 would be 1/4, and you could keep going, and those fractions would get infinitely small. So these are 3 sequences and the whole point of this lesson is just picking up on that pattern, or using an equation to find the next term. So here we have we have to create the sequence here. They give us an equation, and this equation is called an explicit formula. An explicit formula is it's just an equation to find a specific term. So in this case, they give us this equation, and I know there's some terminology here that you're probably not quite used to, but the fastest way to do this is just to create a table. So this table is going to be a little bit bigger than the ones that we'll usually use, but I just want to split it up: term number, term value, like this, and then this is going to be what we call n, and this is what we call a of n. And then the term numbers are just going to be 1, 2, 3, and 4, like that. And then we need to find what a of 1 is. So a of 1 just means that we're plugging 1 into the equation up top. So we have 33 plus 6 times 1 minus 1. Well, that's just 0. So this a of 1 would just be 33. Then a of 2, that would be 33 plus 6 times 2 minus 1. Well, 2 minus 1, that's just 1, so 6 times 1, that'd be, so we have 33 plus 6, this would be 39. And then just one more, and then I think you'll figure out the pattern here. We got 33 plus 6 times 3 minus 1. So this would be 2. 6 times 2, that would be 12. 12 plus 33, that would be 45. And hopefully you can see here that we're going up by 6. Okay, and hopefully you realize that because that is in our equation, we're going up by 6 each time. So the next one would be 51, and you could keep going if you needed to. So this is just using this explicit formula to find those first 4 terms. And explicit formula is nice because you can use it on down the road. So let's say you're using this for a different model, maybe a financial model, saying obviously wouldn't be using these numbers, but let's say you need to know how much money there's going to be 30 weeks or 30 months down the road. You could go a of 30 and just plug the 30 in, which that's nice. That's a nice equation to use. So you can use it to find any term in the sequence that you would like. So this is another explicit formula example, but it's a little bit because our variable is in the exponent, so a little bit different. So once again, I'm just going to create a table. We have n, a sub n, and then we have 1, 2, 3, 4. And then here we would have a of 1, and that would be 9 times 2 to the 1 minus 1. Well, 1 minus 1, that would be 0. Anything to the 0 power is 1, and so 1 times 9, that would just be 9. And you could feel free to use a calculator there if you need to. A sub 2, you have 9 times 2 to the 2 minus 1. Well, 2 minus 1, that's just 1. 2 to the first power is 2. 2 times 9 is 18. Now, it's always important to make sure that you do at least a third, if not a fourth term, in order to get this sequence down. Because I think there's a lot of people here that would want to put 27 under the 3, because they think they're adding 9 each time. But once you write it out, 2 to the 3 minus 1, well, that would be 3 minus 1 would be 2. 2 squared is 4. 4 times 9, that would be 36. So now hopefully you can see that we are multiplying by 2 each time. And so this would be now 72, and you can keep going multiplying by 2 that way. So a little bit different example where we're multiplying instead of adding to get to the next one, but still an explicit formula where you just plug in the number into the variable of n. There might be some times where n shows up in different places. So there might be just this has nothing to do with this example, but you might have something where you have like 2n times 3 to the n minus 1. Well, that means I just plug, if I'm looking for my first term, I just plug in 1 here and I plug in 1 there. I just plug in the same number in both instances where n is. Now, the last example is what we call a recursive formula. And what a recursive formula is that's an equation again, but it relies on another term, and usually that term is the one before it. And so that's the only terminology that I think is a little bit different here, is that right there. A of n minus 1 just means the term before. So basically what it's saying is take the term before, multiply it by 3, and then add 4 to it. And then all this means is that you got to start at 2 because they give us what our first term is over here. So once again, it's important to stay organized. So I would say n, and then we have a sub n, and then they already gave us our first term. That's negative 4. Okay, that's what a of 1 is. So then we just need to go 2, 3, 4. And so for here, we would need a of 2 would be 3 times our first term, which that would be negative 4 plus 4. So 3 times negative 4, that would be negative 12, plus 4, that would be negative 8. Then we have a of 3. Well, then we have to go 3 times the term before, which we just found, that would be negative 8, plus 4. So 3 times negative 8, that would be negative 24, plus 4, that would be a negative 20. And a of 4, we would say 3 times the term before it, which would be negative 20, plus 4. So this would be negative 60 plus 4, that would be negative 56. And then you could obviously keep using that equation to keep going. So it's a little bit more confusing in the terms of what you're plugging in is different, much different than just plugging in the term. You're plugging in the term value that came before it. So it's relying on the term before it. So this is how sequences can be made in a different way. The downside of recursive formula is if you wanted to find what the 100th term was, you would need to find the 99th term, and to find the 99th term, you'd need to find the 98th term, and so that brings you back to where we are right now. So the explicit formula is a little bit more broadly used because it's a little bit more flexible, but the recursive formula is used in different circumstances that we'll be talking about later. So hopefully these examples kind of helped give you an introduction to sequences and series, and I'm always available if you need any help.